Okay, in this video we're going to discuss how you can use OSS Fuzz for Fuzz driver development. All the commands used in this video are provided in the attached Google Slides presentation. Now, pretty much any modern Linux environment capable of running both Docker and Python can probably work for this setup. But for our example here, we're going to show this in a Ubuntu 24.04 machine running under, again, a VM. Now, the main thing you need to consider for your Docker setup is that you've allocated enough disk space for Docker. Depending on the size of the project you used and the number of times you compile it, Docker can quickly consume quite a lot of disk space. So make sure you allocate a fairly sizable VM for this, and also research and use Docker cleanup commands periodically to garbage collect unused images. Now, the first step is to install Docker itself. So I'm going to use a single installer for this curl command. And this will typically take some time. So let's give it a few minutes and we'll be back when this finished installs. Okay, now that that's done, let's go ahead and set this up as a rootless configuration, as I suggest here. Let me paste that in here as well. And they need 2 additional libraries. So let's quickly install these. And if this is already running, let's just do the skip IP tables option. And this hopefully should let us, again with some quick export commands added to your bash rc file, should let us hopefully run Docker in regular mode. Okay, now that that's done and the system is rebooted, let's go ahead and set up OSS Fuzz. Now this will clone the entire OSS Fuzz library into a folder, and finally let's go ahead and pick a project. For the purpose of this video, I'm going to go ahead and pick minizip, as it's fairly small, very quick to compile and so forth. Now all the projects under OSS Fuzz are stored inside this folder we just pulled under the projects directory. So you look under projects, you can see there's roughly 1,300 different projects in here. Just real briefly, this OSS Fuzz folder has a number of useful things. Docs are pretty well very obvious. You've got documentation on various details. You can also pull this information online. The infra directory stands for infrastructure. This has the main helper script, this helper that we're going to be using for pretty much most of our interactions with OSS Fuzz. This also has a number of other tools and libraries. Under here, the same folder, there's something called base images. And if you look under base images, these are the base Docker file base images for the OSS Fuzz configuration itself. So base runner, base builder, base clang, these are all various Docker file setups that can be examined if you want to know exactly how the OSS Fuzz project is built. And we also have finally in here a build directory, which we'll see appear pretty soon. And this build directory will have files that we generate when we use OSS Fuzz, such as the corpus, the out directory, which will store libraries that we build, and working files. So for now, let's go ahead and pull up minizip. If you go into projects, and I'll use autocomplete here, zip. Here we have very few files. Okay, now there's some inconsistency with these OSS Fuzz projects. Occasionally the build script will just be a single line and it'll call some other script inside the project itself. This one does look sizable, so this one looks complete at this point. There's also cases where the fuzz drivers themselves are located here inside the GitHub repo and not the project repo. But since we don't see any fuzz drivers in this particular folder, it's safe to assume that they're in the actual project repo themselves. Now if you look at this project YAML file, this gives you an overview of the project itself, the main page of the project, who their contact is, and what sanitizers you can use. Let's also take a look at the Docker file. Docker file has a couple lines. If you want to try to reproduce the environment to compile the code, you could actually go ahead and run this locally. But for our case, we're going to simply install this and use this inside the Docker setup themselves. You also have a single line here which retrieves all the code of the project. And I'm going to go ahead and run this inside this project folder. This will again clone and retrieve the entire project outside of the Docker file. So now that we have the source files located in this subfolder, somewhere inside this folder is a number of fuzz drivers. Now you can do a number of searches or simply browse through these directories if you want, or you can do a keyword search. Since we're looking for libfuzzer images, I'm going to go ahead and use this grep command. And again, this is also included in, all these commands are included in our Google Slides. And search for this function llvm fuzzer test1 input, because this function will be included in every single fuzz driver. This shows us that under this test/fuzz folder, there's a number of various fuzz drivers. So let's go ahead and go there. And I'm going to go ahead and create a new fuzz driver that we're going to use for adding new code to this project. And just for simplicity, let's just take one of these as a starting template. I'm just going to go ahead and copy the zip fuzzer since it's the largest fuzz driver here. And I'll call the new one new_fuzzer. Of course, once we figure out exactly what this new fuzz driver is going to actually do, you can change the name or make it more appropriate to what the actual functionality is. Now that we've created this new fuzz driver, you'll need to modify the files back in the OSS Fuzz folder in order to actually accept this new fuzzer. So let's go back up again one more level. And to do that, you'll need to look at this build script file. Now I'll go ahead and pull this up in VS Code. And let's go ahead and open our OSS Fuzz container. Zip. And go ahead and use this as a base folder for our project. Okay, and every time this project is compiled, or any OSS Fuzz operations occur, you first create a Docker container dynamically using this Docker file, so these commands are run. And then, second of all, this build script is run. Now the build script has mostly compile commands here, as you can see. And interestingly enough, this particular build script is not typical. Goes and finds all fuzzer executables that end with the extension _fuzzer. So in this particular case, we don't need to do anything. Most of the time you'll see lines in this build script that refer to each and every one of your active fuzz drivers. This one will simply grab all of them, everything with that extension, so we don't need to touch this file any further. So let's go ahead and pull up two files. Let's look at our Docker file, and let's also expand our project folder. If you go under test, fuzz, and retrieve our new fuzzer file here, basically we want to have this file usable and programmable by us, and then basically be able to go over to a terminal window and run a command here which will take our code, including this new fuzzer file, dump it inside the Docker container, and then compile it and test it inside the Docker environment that duplicates Google's OSS Fuzz project directly. So how do we do that? Now, currently, again, the Docker file that we looked at earlier has this clone command. This will clone and retrieve this minizip folder inside the Docker container. But then we need to do an additional procedure to copy this new fuzzer C file into this Docker file. So let me go ahead and use a particular command here. Okay, then what this command does is we'll take this relative directory minizip ng test fuzz, copy the new fuzzer C file, and drop it on the inside of the Docker container, inside the src minizip folder, also under the same folder structure under test and fuzz. So let's go ahead and see if we can compile this and see how this works. Now, in order to compile, we need to look up the actual commands to do this. So let me pull up OSS Fuzz project. Just Google OSS Fuzz. Pull up the documentation. And from here, if you look up getting started, setting up a new project, and then testing locally. Okay, here are all the reference commands for using OSS Fuzz. Now first of all, notice you must be in this main root OSS Fuzz folder, and then run these commands: python helper py build image, build fuzzers with the sanitizer and a project name. We also have check build. We also have run fuzzer, and we have some coverage commands. So let's go ahead and use all of this here. So first of all, as it mentions in the documentation, we must be in this main OSS Fuzz folder. So let's go up a couple levels. And then from here, let's run the command to build this image again, which is this again, build image minizip. And since this will take a few minutes, I'll go ahead and pause the video. Okay, now that that's been built, and by the way, if you do have any trouble with internet resolution errors when trying to build the image, you may have to do a sudo command to run the Python statement to retrieve these images. But now that it's complete, let's go ahead and take the second command, which is to actually build the actual fuzz drivers. That's also shown on that page, which is again helper, build fuzzers, and again we'll specify minizip. And we'll let this thing run. And again, this is having some internet resolution errors, so if you stop and run this as sudo instead, then should succeed at running. However, we have a problem. If you notice here, we have the unzip and zip fuzzer, and it compiled these, but it did not find or compile our new fuzzer that we just created or added to the project. So what can we do? First, let's go back into the same minizip folder. And from here, let's look again at the fuzz drivers for this project. Now, just a quick aside, how does this work? These LLVM fuzzers, if you want to find out more about libfuzzer in general, you can pull up the libfuzzer project phase and read more about it in general. This is the libfuzzer project, and this tells you when you are getting started exactly some guidelines of how to create fuzz drivers, which is very useful. And every project starts off with a function, again, as mentioned before, this LLVM test one input, and the format and data types and various other suggestions. But again, I'll leave this outside this video for right now. So we're finding the new fuzzer, we're finding the unzip fuzzer, and finding the zip fuzzer, and they're compiling, but it's not compiling this one. One frustrating thing you may find is by requiring some of these projects to actually have references directly to these files before they will compile. To determine this, let's do a search for references to, let's say, zip fuzzer. So, searching all the source code for explicit references to zip fuzzer, we get pretty much only the files themselves. So let's try just zip fuzzer by itself. Okay, and here you find something interesting. You can see in the CMake lists.txt, there's two references. One for configuring fuzz test as zip fuzzer, one for installing. This is on line 976 and 980. And I bet if you do the same search for our other fuzz driver, the unzip fuzzer, we'll see the same thing. There's two different lines. So let's go ahead and pull this CMake lists up in our editor and see what we can find. So again, pulling up the main project itself, CMake lists, and this is the wrong file. This is under test and fuzz. Let's pull up this CMake list file. Okay, here we are. So right here near the bottom of here, we find our two explicit references to zip fuzzer. So let's just go ahead and create new references to our new fuzz driver. And same thing here. To get a reference here. So now we have two files that have been modified. We've got our new fuzzer.txt and we've got the CMake lists. So technically we need to go back under the Docker file and make an explicit reference to copy this modified file into the source folder. So let's go at the bottom of the file again, add one more reference. We're going to copy again just CMake lists from here into the main project folder. And let's compile one more time. And again, this has to be run. Okay, and as you can see, we still have the same references. So it's not installing yet. And I'm guessing because this file did not get saved, let me go ahead and save our changes to both this and to CMake lists. Let's try it one more time. Okay, now you can see new fuzzer is now being compiled. You scroll up here. Yeah, again, it is compiling it, it is linking it, and building targets. So we now have new fuzzer being created. Now, this is a little bit clumsy. Do we need to actually make a new reference in our Docker file for every single modified file? Yes and no. There's two different approaches we can use for building this project. Now, this approach is great if you're making only a few changes to a few files. We may not have to make any more modifications besides these two. Every single time the project compiles, we're grabbing the very latest copy of the code from GitHub and then dumping our two modified files onto this newly grabbed code and compiling it. However, there's a different approach we can take. Instead of using all this, we can simply not bother copying anything in, and instead of actually retrieving this minizip ng folder from GitHub every time, we can specify that OSS Fuzz pull this minizip ng folder up locally. So for our purposes, let's first disable and mark out all these lines. We're going to make it so nothing is pulled, nothing is transferred. And compare yes. If you run, it's going to crash because, again, there's no source code. But then if we run this command, this again is the same thing. We're just running build fuzzers, the project, and then providing the source code that we want to dump into the project, which is again under projects, minizip ng. And again, of course, you're welcome to put this source code anywhere you want and specify it here. They should tell it to build using this directory mapped into the source folder. And again, let's run this as sudo and as you can see, we have the same result. And that way we don't have to make any other Docker file modifications. These Docker file changes aren't necessary, and we're taking the source code entirely from this subfolder. Now again, the downside of this, of course, is that we're only working from our own copy. If any upstream changes occur on GitHub, we'll never see them until we manually run another git clone command or update our image here. But then that's not usually too much of an issue because most of these projects won't be changed too frequently. just to test our build, let's go back under and again edit our new fuzzer. If we let's say if we corrupt this file, let's make some change. Let me misspell data and verify that this is actively compiling this actual code. If you run this, you then see our build error. Yes, there's no undeclared data. Data does not work, so we can correct our typo. Rebuild, and yes, see that the error is definitely fixed. Now let's go back and see what we can do to get some code coverage information or code coverage reports. Looking back at the website under the OSS Fuzz for reference information. Now this says basically you have to first build the image locally, build your fuzz drivers, and in order to build coverage data, we need to actually run the fuzz driver for a while and generate a corpus from the previous fuzz driver step in order to get some data. So again, we need a total of 3, technically 4 steps here. We first need to run the fuzz drivers for coverage data. Then we have to run and recompile the code for coverage. And then we have to finally run a actual coverage statement down here to generate the coverage report. So let's look at this and look at this in some detail. First of all, to run the project, this tells us again basically how to run the fuzzer, what the path to corpus directory is. Let's see if we have any more options. So going back to the command prompt here, looking at run fuzzer and then putting this /h. Let's say we want to run it not continually like run fuzzer will do normally, but we want to run it for only a maximum of 30 seconds. What can we do here? Now here we see a lot of different options. So as you can see, it looks like what we're telling it here is that we're going to give a project name for minizip, then a fuzz driver or fuzz target, which is our new fuzzer. Then we're going to pass it an additional argument. So let's give it an argument of 30 seconds. And we've got unrecognized argument. This is actually not documented, but if you must use like the 2 hyphens in order to pass additional command line parameters to the fuzzer. So again, same thing, slight variation. And we're getting another error here. Path provided in corpus directory does not exist. So let's go ahead and create that directory. And try this one more time. And here we're getting permission denied errors. So let's go run this as sudo again. And it's grabbing the base runner image locally. And then hopefully run for 30 seconds. So let's let that finish here. Okay, and as you can see, it's starting to run. This will run for a total of 30 seconds, so I'll pause the video again. Okay, now that it's done, let's go ahead and run and rebuild the project with the coverage sanitizer, as the instructions show. I'll just run this as sudo. And again, same concept. Build fuzzer as coverage sanitizer, minizip, and then give it our source folder, and then let this run. Now that it's rebuilt for coverage, let's go ahead and generate a coverage report, which again is this final command, as you can see here. And we're getting, again, permission denied error, so we also run this, a sudo. Okay. Finally, this will give us a hyperlink to browse this coverage report as HTML. So let me go ahead and open this link up. And here we go. So we have 32% code coverage. And we've got data under a source folder, minizip. And here we have various source code files. As you can see, the number of lines of code coverage for each file. Under test and fuzz, we have the fuzz drivers. Now notice this is only the new fuzz driver. So this is code coverage details for our fuzz driver, and since we're running the fuzz driver directly, we should have pretty good code coverage. Again, this thing ran 53 times, and that's 30 seconds. Sounds pretty good. And we can see exactly by browsing these source code files exactly what's covered and what's not. So if I pull up, for example, this file, you can see that these lines were executed 2,000 times, which is pretty good. Here's some code that was not covered at all. It was executed 0 times. And again, that has to do with a different cryptographic library being used. Apparently that library was not being called, so that was not run much. Let's look at this file. Here's code that was run 82 times. Here's code that was run 3,000 times. Again, most likely because of some loop function which called this code multiple times. Here are lines which were returned code executed 0 times. Again, we hopefully did not run into any errors or worry about string errors being called. Here's a stream read command, which this function did not get called at all, and so forth. So again, these code coverage reports will tell you quite a bit about, in that 30 seconds, what code was executed, what code is not executed, and hopefully give you some ideas of what's covered and what's not. Now let me go ahead and close this again for a minute and go back to our command line. You can cancel this by pressing Ctrl+C. One thing you can also do is execute all of these commands, all 4, in a single command. This is also, of course, included in the Google Slides if you want to cut and paste from there. If you paste this in, you can just combine all these commands: build fuzzers, run for 30 seconds, build covers for sanitizers for coverage, and then run this sanitizer report. And again, you may want to put some sudos in for these particular statements, and you can run this one more time. And this will do basically the same thing. Okay, here's the same commands with sudos. And if you run this, you'll see it'll basically just execute everything in sequence. Build, running the fuzzer, and so forth. Now, one thing you'll notice, if you remember our report, is that our code coverage was only about 32%. If you pull up our details. One thing you can do is look up how much code coverage the OSS Fuzz project has when they're running this code for minizip. If you search for OSS Fuzz, scroll down a bit, and pull up this page, this introspector reports. Pull up project overview. Let's look up minizip, and then get code coverage reports. Looks like the latest this was run was on the 11th. So let's click on this report. You can also put in different dates, like if you want to see what this report was run in 2024. You can see in 2024 their code coverage is only 58%. So this date field can be placed with any valid date, at least that date that has a report. But returning to 2025, you see their code coverage is 76%. So how come they are getting 76% and we're only getting 32%? Now, the answer might be a little too obvious. If you look in their code, under their fuzz folder, you see they're running two different fuzzers. We're only running our new fuzzer. So what you can do is, instead of just running one fuzzer and checking the fuzzing report to get code coverage, you can run all of the fuzz drivers for the project and then combine their corpus data into getting one combined report. So let's go ahead and do that. First of all, let's go ahead and cancel this. So first of all, you'll have to create, as we did earlier, some blank corpus directories for the two existing fuzzers. So let's create one for zip fuzzer, one for unzip fuzzer, and let's look at the help page for the coverage report and see how we're going to do this. And you can see from this no corpus download, if I use this no corpus download, it will use corpus data locally from the build corpus project fuzz target. So again, let's combine all the coverage reports from all three of these into a single command. So in English, what we're going to do is we're going to build the fuzzers. We're going to run first one fuzzer driver, a second one, and a third one, rebuild for coverage, and then check the coverage report. Okay, so here's the combined command. Again, build fuzzers, new fuzzer for 30 seconds, unzip fuzzer, zip, sanitizer, and the final no corpus download statement. And again, of course, this can easily be put into a shell file or something similar. So let's go ahead and let this run and see what we get. Okay, and as you can see, this is finally done. So if we open this new code coverage report, you can see we have 73% coverage, which is again quite a bit higher than 36. Now if you compare the code coverage for the actual OSS Fuzz project, notice they're getting 76% coverage, but we're only getting 73% coverage. The reason is because they're running this for, I believe, for at least 24 hours, while we're running our report for only 30 seconds. This is a fairly small project, so there's not much difference here. If you're working on a very large project, you might want to give it more than 30 seconds to get these numbers closer. A 30-second run might be quite a bit different than the code coverage of OSS Fuzz. Finally, if you do start working on creating a new fuzz driver for this project, you might want to start with a baseline. Write down and record exactly what the initial 73% code coverage that you get within this first 30 seconds of coverage. So if you make any improvements, you should be able to see if your improvements are above or below your initial baseline of 73%, not the baseline of what OSS Fuzz is. This allows you to compare one 30-second run prior to your changes to a 30-second run after you've made modifications to see what details have improved. Finally, this project lets you run and create another report, which is fairly useful. This is known as Fuzz Introspector. Let's go ahead and stop this coverage page here. If you look at just the helper script /h, you can see all the features of the helper script, which is again running coverage reports, and also it can run something known as an introspector report. So let's look at the help page for introspector. Here we have helper introspector, seconds to run, and project and source path. So let's go ahead and run this. This is a very simple command. I assume this will take the local code coverage, the local path, and let's again supply this with our source folder, our custom minizip source folder, and get a command such as this. Now, unfortunately, there's no simplified version to get coverage data, but there is a simplified version, as you can see. Oh, and again, we're running into sudo. So, but this will run gives a Fuzz introspector report. And I'll go ahead and pause this video while this is running. Okay, now that that report's done, it's basically letting you know that you can run this particular command in order to start a web server. So let's go ahead and execute that command. And this pulls up a new web server. And then what you do on this page is look for Fuzz report. And this gives you a Fuzz introspector report for our project. Now this has a lot of useful information. It'll show you the static reachable nature of the Fuzz drivers. It will give us reports and details of all of our Fuzz drivers, including the ones implemented earlier and our brand new one, which we haven't done much to configure. It will give us a lot of analysis and suggestions about other functions, other interesting functions, other functions with high reachable untouched code that we might be able to use to generate new code coverage with. And again, you can mess around with this quite a bit and look for things with high undiscovered complexity that hasn't been reached and try to combine these into a new Fuzz driver. It can give you details of exactly how your Fuzz driver is operating. You can pull up, again, if you scroll down just a little bit, details about exactly what functions are called straight from the Fuzz driver. You can look at the source code of your code and see basically how it branches down, which sections are reached and unreached. Again, what areas are not being touched by this particular Fuzz driver, what areas are being touched, and so forth. So again, this is a very useful tool to give you more hints about how to debug your Fuzz drivers that you create, and also give you ideas of what profitable sections of the code can be hit.